Okay, so for number 14 on the bookwork, it's asking me to prove that segment BC is congruent to segment DF. So it's going to be kind of a hefty proof. There's a few steps we need to take. I have some given statements and I have a diagram that is given to me. So I'm going to go ahead and start with step 1, and I'm going to say that I'm just going to write out my given statements as step 1. I'm going to use those. So I'm going to say that segment AB is congruent to segment FG. I know that. That's just given to me. I also know, I'm going to put them in bullet points, that line BF, and I need my little line notation, bisects segment AC and segment DG. My little segment notation. So I know those two things. I'm going to write in red my givens, or I'm sorry, my reasons. So this reason right here for number 1 is just given. That's just given to me. All right, so step 2 over here. I'm going to start by saying something about segment AC. So taking this step by step, I know that BF, line BF, is a segment bisector because it bisects segment AC. Well, in order for something to be a segment bisector, it has to hit a segment right at its midpoint. So it tells me it's a segment bisector, which means I can say that point B is the midpoint of AC. So I'm going to say that point B is the midpoint. I'm going to say midpoint, M-I-D-P-T, period. Midpoint of segment AC, little segment notation. That's my next step. And my reason for that, it's actually because I know the definition of a segment bisector. The definition of a segment bisector can be written as an if-then statement. So if a line is a segment bisector, then it hits a segment right at its midpoint. And I literally just said that from step 1 to step 2. I created an if-then statement. So my reason for number 2 is the definition of segment bisector. I knew that. All right. So step 3, let's think about what we can say then. Well, if we know that point B is the midpoint of segment AC, I can say something about segment AC. So if B is the midpoint, I can say that from A to B, it's the same distance as from B to C. Because a midpoint splits a segment right in half. It creates 2 equal parts with equal distance. So I'm going to say that AB, segment AB, is congruent to segment BC. Because I knew that B was my midpoint, and I knew midpoints split segments in half. So I know that number 3 is true because of the definition of the midpoint. Definition of midpoint, M-I-D-P-T, period. All right, so step 4. Actually, I'm going to go ahead and add my little arrow between step 2 and step 3 because I created an if-then statement based on my definition. I knew that if B was my midpoint, then it created 2 equal segments. So that was my if-then statement. For step 4, I'm going to fit it right over here. My step 4, I'm going to go ahead and say something about segment DG now. I'm going to move on to that one. I'm going to say that F is my midpoint of DG, and I can say that because I know that line BF is a segment bisector, and in order for it to be a segment bisector, it has to hit right at the midpoint. Well, it tells me it's a segment bisector, and it bisects DG, so I know that wherever it hits DG, which is F, is my midpoint. So I'm going to say that point F is the midpoint of segment DG. And I know that because of the definition of a segment bisector. Because I knew that if a segment bisector hits at the midpoint, if a line hits at the midpoint, then it's a segment bisector. So I said that if F is the midpoint, then, no, I'm sorry, I said that if if BF is the segment bisector of DG, then it hits at the midpoint, which is F. And I know that because of the definition of a segment bisector. So what I'm going to do is I'm going to actually draw a line from 1 to 4 because I knew the if-then statement was created from 1 to 4. I said that if line BF bisects DG, then F is the midpoint of DG. All right. So my next step, I'm going to go ahead and scroll down just a little bit. My next step, step 5, I'm going to say that for step 5, I'm going to do just like I did on step 3. Because I knew in step 3 that B was the midpoint of AC, I could say that AB and BC were congruent. Well, same kind of thing I'm doing for DG now. I know that F is the midpoint of DG, so I'm going to say that DF is congruent to FG. I know that because I knew that F was my midpoint. I figured that out. So the reason for number 5 is just the definition of a midpoint. I know that. All right, so for step 6, I'm going to use a different sort of reason. I'm going to do something a little different here. I'm going to use something called the transitive property. Now, what I'm going to do is I'm going to look at step 1 and step 3. On step 1, it told me that segment AB was congruent to segment FG. And in step 3, I said that segment AB was congruent to segment BC. So if I know AB is the same as FG, AB is also the same as BC, I can say for step 6 that FG, segment FG, is actually congruent to segment BC. And that reflects syllogism, so I know that this is the transitive property. All right. So my last thing I'm going to do, step 7, I know that what I created in step 6 and what I have in step 5 can actually be combined a little bit. So let's look at this. I know in step 5, I said that segment DF and segment FG were congruent. And then in step 6, I just said that FG was congruent to BC. So if DF and FG are the same, and FG and BC are the same, I can finally say that segment DF is congruent to segment BC. That's what I was actually trying to prove in the beginning. It said that I needed to prove that BC was congruent to DF, and I just did that. So the reason here would be my transitive property. And I know that it said I needed to prove that BC was congruent to DF. Well, I have DF is congruent to BC. I just have it flipped, but that's okay. When you have a congruent sign in the middle, you can read it either way. DF is congruent to BC, BC is congruent to DF. It doesn't matter. So we are done.